We will get moving here. Welcome, everyone. My name is Dr. Jim Lani. I'm the CEO of Intellectus 360, which has the Intellectus Literature Review, Intellectus Statistics, and Intellectus Qualitative. On the call is Melissa Moran, the president, Ashley, who can help faculty with any needs that you might have with respect to demos or trials or courseware. And Samantha is here to assist any students with the 20-minute needs assessment and so forth. Feel free to use the chat of the Q&A at any point, um, at some point, um, particularly with your questions or concerns. I mean, I really, feel as though these webinars, this one I enjoy in particular, but these webinars are for you. They're about your questions, where you're stuck. If you're a faculty, you might have other concerns in assisting students or for your own journal publications or things of that sort. So feel free to ask and get your needs met during this time together. And with that being said, I entitled this "Cracking the Data Analysis Plan." Having been consulting for going on 30 years, data analysis plans and quantitative was one of the real sticking points for students and faculty. They kind of took a class in stats maybe a while ago, um, but it's not a common thing to be thinking about the appropriate data analysis plan to examine study aims or research questions given the kind of level of measurement of your data that you have. So I will lay out a pretty simple formula for doing that, and then you'll share, whether this makes sense to you. And if it doesn't, that means someone else doesn't make sense to, and I'm happy to say it in a different way. So everyone's going to have to figure out what test they're using to be sure. Students guess at it sometimes. Um, the methodology, that is the sticking point in quantitative methodologies, what statistical test to use. But it's really important because that methodology chapter serves two purposes, at least, three purposes. One, it helps you figure out what test I'm going to conduct after I collect the data. And you should know that before you collect the data. I too often see folks that have the data, but they're not sure about the analysis. It's the wrong order. So you want to kind of have in your brain, yes, I can do this test to examine these questions. That's one. Secondly, the IRB is going to want to know what you're doing. So do you have you know, a reasonable way of approaching or examining these questions? So they're going to want to know that, all right? And as it turns out, they're going to want to know that because you know what you're doing. But secondly, the sample size determination is going to be based on the test that you select. So let me repeat that the sample size or power analysis is based on the statistical test that is selected. So you need to know that, okay? If your minimum sample size is 15 or 30 and you can get three, you need to know that sooner rather than later. The third reason to have a data analysis plan is that your methodology should act like a cookbook. Your participants are the cooks, um, so to speak, and the materials section is the ingredients, and the procedure is how you're making that cake. So, in terms of good science and replicability, you need to have those components. Okay, who's doing what? What are you giving them? And what are they doing? All right, so that's really important that people, your partner, your neighbor, should be able to take your methodology and repeat baking of that cake. They know exactly who the participants are, what instruments are, and how you're giving it to them, including consent form. Okay, so that's the material as well. So those are the reasons why data plans are really important. Um, so I will show you a quick formula to how I approach it. Might be other approaches. This is how I do it. And it's kind of worked for, decades. So it kind of gets us there. So the simple formula is such. Your research question has to be, or study aim, has to be phrased in statistical language. I know we probably have a lot of DMPs on the line, and you're doing PICO questions, but when you boil down that PICO question, you're saying what's the relationship between these variables, or are there differences from pre to post on the C scale, or whatever. So at the end of the day, you need to figure out what are the variables and what kind of relationship or prediction or differences are we seeking with respect to those variables. So that's an important piece of it. The other piece is the level of measurement of the variables. What do I mean by that? So I'm going to get into that, but basically there's only three levels of measurement in the world. I think the next slide gets there. So you need to know if it's nominal, ordinal, or scale. Okay. And you need to have the research questions in language that kind of um, foreshadows the kind of analysis. Okay. So let's um, so the statistical language. There's lots of ways of phrasing things. People say relationships between, people say correlations between, but basically things boil down to a vast majority, like 95%, okay, of things will boil down to these kinds of phrases or words that will kind of evoke the kind of analysis, okay? So, is variable A related to variable B? Very common, okay? Are there differences on some outcome variable, like confidence, by some other variable, by gender, by time, by something, okay? And then there's kind of the prediction world where we want to see if a variable or a set of variables predicts or impacts another variable. And people want to know that. Um, okay. So the simple case is to use three kinds of words: relationships, differences, prediction. And here's some examples of what that might look like. Okay. Relating study hours and GPA. That seems reasonable. Okay. Differences in some test scores or any kind of scores or subscale or scale by some teaching method. Could be online, in person, hybrid. It could be method A versus method B, things of that sort. And then wanting to predict some health satisfaction or health based on some factors, perhaps income. But as I said, there's two pieces to that equation above. One of them is the verbiage, and the other one is the level of measurement. So the level of measurement, as I say, goes into three buckets. One is name only, okay, nominal. That's the mnemonic. And it's just really labels of things. There's no hierarchy. There's no equal distances between them. It's a male, female, red ball, green ball, blue ball, okay, whatever. All right. So that's it's just naming of things, okay? Ordinal has the names, okay? Horse comes in first, horse comes in second, horse comes in third place. So it has names, as does nominal, but it's ordered, right? First horse comes in, second horse comes in, third horse comes in. But the interval or the distance or the volume between those labels are not equal, okay? So the first horse can come in, second horse can come in a nose later, third horse can come in 5 lengths later, okay? So we still have the order, but it's not equally spaced, so to speak, in between those. And the icon is kind of a bar graph for that. Likert type scales there's a whole conversation about Likert type scales. At the end of the day, when you have a Likert type scale, be it 4-point, be it 5-point, be it 7-point, they may well be ordinal at the individual level, okay? Like getting the question correct or incorrect, that's nominal at the individual level. But once I start adding or averaging, I am now clearly going to be in scale land. So scales also have labels, 1-inch, 2-inch, 3-inch. It has an order, 1-inch, 2-inch, 3-inch, but it also has equal spacing in between them. And the ruler is the icon for that. Age is clearly well, it's truly a ratio level variable. You could be at, I guess, 0 before you're born. But I bucket scale and use synonymously, and for the analysis, I bucket scale and continuous and ratio and interval all into the same bucket. Doesn't have an impact on the statistical test. Okay, so you should know those. All right. So simple language, your measurement is one of three. Okay. All right. So let's talk about some of the tests by language. So if I'm relating a nominal variable and a nominal variable, we're in chi-square land. Okay. Where we're just kind of looking at frequencies of males and females and selection of Coca-Cola or Pepsi. All right. Once you get into nominal ordinal, also chi-square land, once you have ordinal and ordinal, or ordinal or scale and scale, or ordinal and scale, you really need to a Spearman correlation. And the key there is that one of the variables, at least one of the variables, is ordinal. And scale, we're in a Pearson correlation. So when it comes to relationships, we're either in chi-square land or correlation land. Okay. And you'll get a copy of, and we'll get a copy of this slide. So there was that question there. When it comes to looking for differences, okay, differences on emotional intelligence by male, female, differences on emotional intelligence by old or young, or whatever, okay. Once you have a group or an independent variable that has just two levels, you're in t-test world. Could be independent t-test, could be paired t-test, but you're in t-test world. Once your independent variable, just stays nominal, has three or more levels by, income, low, medium, high, or something of this sort, red box, green box, blue box, you're in ANOVA world. If you're looking at scale by ordinal, same thing. And if you're looking at an outcome variable or dependent variable A that is ordinal in nature, and you're looking at it by some independent variable, which is nominal, you're in the Mann-Whitney or Kruskal-Wallis world. Okay. The Wilcoxon, the Friedman, the pair t-test are all same participant at different times. Okay. Baseline, a post-test, or whatever. All right. So the key here is we're looking at differences. And ANOVA's t-test, most common, are the tests for that. Okay. Once we get into prediction, things get relatively easier because the only thing that matters is the level of measurement of the dependent variable A. So when it's binary, yes, no, live, die, correct or incorrect, we're doing a binary logistic regression type of analysis. You'll notice in the middle column that it doesn't matter really how many variables you have, and it doesn't matter the level of measurement of the variables you have. The key to regression, does this variable or set of variables predict that outcome variable, also called the criterion level variable in regression world. So if it's binary outcome, binary logistic. Nominal with three or more, multinomial logistic. Ordinal outcome variable, okay? Ordinal regression. And if it's a scale level measurement, outcome variable, okay? And you're in prediction mode, all right? You're doing a linear regression. They sometimes call it multiple linear regression if you have more than one predictor, but we're in linear regression world, okay? So what type of research question do we have? We're study aim, relationship, difference, or prediction. There are other variations. Some studies are purely descriptive in nature. I said it was going to go up 15%. I do a subtraction, okay? Um, so, but those again cover quite a bit of territory. Level of measurement, nominal, ordinal, scale. And for the differences, we need to know for that independent variable, typically under the control of the researcher, how many groups do we have? 2 or 3 or more, okay? And there's a quick reference down here for looking at those 3 buckets of questions and the types of analysis that are associated with that. Intellectus Statistics helps you get there. We have a built-in decision tree. We'll get to an AI decision tree at some point. But at the moment, you can kind of walk through this tree, which I'll show you, which kind of helps you figure out based on your independent and dependent variable and whether you're predicting or looking at differences. We'll walk you through to get to the test at the end of that tree. It does offer 60 different tests and then some. We have automated assumptions. When you write that cookbook and select that statistical test, more often than not, there are different assumptions associated with that test. You have to test those assumptions, okay? So there's assumptions associated with that. And both in the data plan, which functionality, which I'll show you, but then also in conducting the test, they need to be documented in the method in IRB. They need to be assessed when you conduct it, and need to be, interpreted thereafter. Okay. And we do a lot of the interpretation of quantitative analysis, quantitative assumptions. We also have a scroll over for the graphical assumptions, which you can support you in interpreting that. And then our results happen to be in APA format 7. I don't know. They're gonna change some point. They're only at 7, but at some point they're gonna want to sell a new book, and there'll be an 8th out there. And oftentimes those additions just kind of goes from italics to bold or whatever. I don't think there's been any revelation in these versions. Nevertheless, 7 is what's out there. 7 is what we use. When it changes to 8, we'll change to 8. Okay. And then as a place to log in, I'm happy to hop onto someone's project too. If you upload data, and I guess show you that briefly. If you want to share that, that's fine, or just walk along with me. That's absolutely fine as well. Okay. While folks are logging on, I guess I'll get to and briefly touch on the connect to us. As I mentioned at the top of the hour, Melissa can support students. Ashley can support faculty. Melissa supports the boss, and a QR code so schedule 20 minutes with me. If you're faculty, I'm happy to give you more time. Our website and our phone number. Okay. We'll get to questions and answers. Don't be shy. And let's go ahead and get to the demo, okay? Let me just do this, just so people could take a picture of that with their phones if they want. So they have that contact information. I guess I'll linger there for just a moment. All right, and then let's get to the demo itself. So this is the Intellectus Statistics tool. You'll notice that it's web-based, so you never have to upload the tool, refresh it or whatever. Well, you may have to refresh it on rare occasions, but um, you don't have to update it. That's where I was going to. So make this a little bit larger. Just to give you the quick 10,000 foot view of this, projects is where you can upload data from different files or use an example data set. Teachers be aware of that. There's different courses um, with competency-based courses. You can paste or a flat file like an Excel file or CSV into this as well. We also have a data management functionality, which allows you to do basic things. Most things, though. Primarily, folks use the variable calculator if they want to then calculate some composite scores. You'll want to be able to download your managed data. So I may have uploaded this data, but I'm going to need to know, okay, what any scores that I've computed. There's different plotting functionality. Add in a plot. Okay. I wanted to actually do that. So it shows the 10 types of plots. I see, can I replace my SPSS? Boo to SPSS. Of course you can. And the analysis is here. Here I just ran some descriptives, paired t-tests, and the scatter plot. And you can see all the different tests going on here. More to our topic is the decision tree. So in that decision tree, you can see that we talk about differences, prediction, relationships, and if I'd like to predict an outcome. And again, the key thing is the dependent variable. And if it's scale, I'm doing a linear regression. And then you can jump right to it. Should you want to have data, if you have data uploaded, you can jump to it right then and there. So you can play around with this thing. You can't break it. All right. So that's the decision tree. And it gets you to, I mean, the caveat is it gets you to many of the analyses I just talked about. It does not get you to time series. It doesn't get you to other kinds of things. So, but for most cases, we're here, okay, with respect to the analyses to the right. Once you know you're doing a linear regression, it's helpful to be able to have some kind of a data plan template. And you can, under the data analysis plans, you can click on the test and you can see kind of, I know DMPs don't use hypotheses or research questions for that matter, typically. But you can see kind of an editable, you can download this, an editable data analysis plan, importantly, including the assumptions of each of the analyses. So that's kind of an advantage there. And then it's all referenced as well. Okay. The other piece that I haven't talked about, but I touched on briefly, which is different tests have different sample size requirements. So doing a paired sample t-test, medium effect sizes are probably good for vast majority. But know that you're in that 15 to 34 range, okay? Is a ideal sample size if you're doing a paired t-test, if you're using a critical alpha of 0.05, and the standard is 0.80, which is power of 80%. That's what should be in your methodology. That's what should be in your IRB, okay? And just to know that that's there as well. Okay, questions? Or Melissa, things that I've missed. I have one message here. I know today you're covering quantitative. I'll let someone address qualitative needs. Okay.
We have a hand raised too.
We have a hand raised. Okay. Q&A. Okay. Hi, Carol.
Hi, I have a question about, I guess my variables are scale variables. Could I still do paired t-tests to compare means on, I'm doing a dissertation and my predictor variable is congruence between leadership's actual behaviors and employees' implicit leadership theory, ILT. So if I wanted to do a paired t-test between looking at my survey results about what they feel about leadership actual behaviors versus their ILTs, and both of these are scale, would that work?
So I want to back up for a moment. So you
Okay.
kind of are conflating a couple of things there.
Okay.
One, so let's just take all three ways of phrasing. So we have two variables, okay?
Yes.
Behavior, ILT, both scale. So we can ask a question. We can ask the question, is there a relationship between them? Okay.
Yes.
Perhaps when behaviors go up, ILT goes down or whatever. Okay. So with two scale variables, we're kind of in that correlation land. Okay.
Okay.
The other way of phrasing that is to say, hey, gosh, I want to predict ILT from behavior, in which case a linear regression is appropriate because we're in prediction world.
Yes.
And we're predicting an outcome variable that's scale. So that's a linear regression.
Yes.
The t-tests are looking for differences. So I don't think that that's appropriate here unless I want to take leadership behaviors, dichotomize them into high and low. Now I have a group with two nominal variable or ordinal high and low behaviors. And I can say, are the differences on ILT by high and low behaviors? So that's three ways of slicing that apple, okay, or those variables. So the phraseology that I mentioned is really important. So the phraseology would be as such, you know, is there a relationship between behavior and ILT, Pearson correlation? Does behavior predict or impact ILT? I'm in regression.
Mm-hmm.
Or are there differences on ILT, okay, by high and low behaviors?
Okay.
I'm getting the sense though, which I don't mean to do, but
Mm-hmm.
sometimes, Levi's came out with like you can customize your jeans,
Mm-hmm.
and they had 35 options, and people didn't buy any of the options. It was too confusing. So,
Right.
uh, so I fear that I just did that with you. So let me ask, what is your main, do you actually want to, so prediction would be really good. I think you should do a correlation no matter what. Okay. Are these things related or not? Okay. If there's no
Right.
relationship, maybe we're done. Okay.
Okay.
So
So,
I would definitely do the correlation. Are these two
mm-hmm.
things related at all? Okay.
Okay.
Prediction is very helpful if I now want to literally predict people's ILT scores. I can now not only say, does it predict and how so? Well, when you increase leadership scores by 1 unit, you increase ILT by 5 units. So it gives you that kind of granularity. Okay.
Okay.
That's
Okay.
helpful. The regression is also helpful that if I knew people's behavior scores, I can predict someone's ILT scores. So it's nice for prediction as well as describing not only that there's a relationship, but how that goes. So let's just do that real quick.
Okay.
So I think this will be helpful. So I have behavior here. I have ILT here. Do you actually have your data set by any chance?
No, I'm
Okay, that's
in
fine.
the proposal stage.
we have a 7-point scale, say ILT. Oops. Okay. Let's also imagine that we have a behavior high-low. Let's assume that this is low. Okay. Let's bucket the fours and highs for the heck of it. Okay. So let's just put names to these things. Okay. So this is theoretically how you can have your data in behavior scale, ILT scale, ILT scale, and behavior high-low nominal. So the first thing you want to do, and it should be part of every analysis, is do descriptives.
Mm-hmm.
Under descriptives, add variables, check all. So, and the reason you want to do this, two things. You want to do this, and then you want to read this. You can see how the high-low bucketing worked. You could look at the mean and standard deviation of your behavior in ILT. I accidentally put in a 34. Well, that would show up as a maximum. And I would say I made a data entry error. So you want to look at those descriptives and then correct any data entry errors. If I was looking at relationships, I'd do a Pearson correlation between my behavior and ILT. You'll note that it's scale, and you'll
Mm-hmm.
note that the nominal variable high-low did not come up. So kind of
Right.
streamlining it. And if we correlate these two things, we can see, hey, yippee skippy, there's a strong positive correlation between behavior and ILT,
Right.
saying that as behavior increases, ILT increases, but it doesn't tell us how it increases. It's a strong positive correlation, significant positive correlation, but it doesn't say in what way that is, okay?
Mm-hmm.
So that's the relationship question. The prediction question is under regression. And when I click that, I can put in my outcome variable. I can click my predictor variable. Okay. Just note this in
Gotcha.
your tutorials throughout.
Okay.
And here for regression, I mean, the correlation had assumptions too. Okay. The regression also has assumptions that we are articulating here with a scroll over here. But to kind of get to the meat of it, you can see that this was also significant.
Mm-hmm.
Okay. The R square, so this is more information that of all of the reasons why ILT can vary, um, behavior represents or accounts for 88% of those reasons. That's kind of a big number.
It is.
The other thing it does is that it gives you two other things. One is this. What is that relationship? Well, when I increase behavior by 1 unit, ILT will increase by 0.66 units.
Mm-hmm.
That would be important if you have several predictors and you're a company and wanted to know what to focus on. You'd want the one that has the largest impact. Okay. So
Mm-hmm.
if behavior is increasing ILT by 0.66, but some other variable B is increasing it by 3.2 units, that might be a better focus.
Right.
The last part of the regression is the regression equation, where I can now plug in someone's behavior score and get to some theoretical ILT score. So that's also an important thing to know that regression offers you.
Mm-hmm.
The third permutation is really a t-test permutation.
Mm-hmm.
which is asking about differences. That are there differences on my outcome variable, ILT, by some independent variable, okay, behavior high-low. Notice it's nominal,
Right.
and notice it was the only option available. So if I'm looking for differences on ILT by behavior high-low, like the other variables, there's assumptions associated with this. I won't go through that right now. And here we can see, hey, yippee skippy, there was differences, okay, on
Mm-hmm.
ILT by behavior. You can see the means for each one of them. It's a different kind of question. It's a different kind of analysis. And it's a
Right.
different kind of finding that, yes, there are differences there, and that those with high behavior scores, in the high group that is, had a greater ILT, okay, compared to those in the low behavior, okay, which had an ILT of 1.5. So think about your question, think about what you want to know, all right,
Mm-hmm.
and then select the test that's appropriate for that question. And you can see we managed some data.
Yes.
Pardon me. So I managed some data over here, but you get to do that, okay?
Okay.
Did I answer your question or did I confuse you? How are you doing?
No, yes, sir. You answered my question.
Very good.
Absolutely.
Terrific. I wish you a good week.
Thank you.
My pleasure. Um, okay. Uh, I'm working on mixed method, quant and qual. Who talked you into that? I know people do that, but for people on the call, if you can select one methodology rather than two, do that if you're a student. I mean, if it really requires a mixed method, but typically you can do a purely quantitative study and add a couple open-ended, call it quantitative. If you want to do qualitative and do interviews or get narrative responses, do that. But I would dissuade you from that. Nevertheless, um, I have a Mancoba statistic with three covariates. Okay, one independent variable, two dependent variables. How and which substitutable more valuable for my study? Same thing we've been talking about, which is, the Mancoba is a particular question that it's answering, which is, are there differences, simultaneous differences on my dependent variables by some independent variable controlling for these variables? That's a reasonable question. So, so, um, so yeah, I mean, that seems okay. You can do that. Okay. All right, next question from Tina. I'm doing a paired t-test pre and post, de-escalation training and simulation to see if nurse confidence levels improve to manage disruptive behavior in emergency room. Awesome. So the trick there with the paired t-test is, as the name says, they need to be paired or matched. So you want to be able to make sure you have participant one at pre is matched or paired with participant one at post. So that's the key there. And paired t-tests seem very reasonable. Now I'm assuming that you're doing confidence pre to post. So yeah, so you have one outcome variable, and you're gonna see if the means differ from on confidence from pre to post. Cool. Other questions?
And you're also welcome to raise your hand if you have questions and we'll unmute you.
Fine. Just for that mixed method person, just know that we have Intellectus qualitative tool. I know this is kind of outside of what we're talking about, but also a web-based tool that will help you thematize, excerpt and thematize in 10 minutes. It will save you 50 hours if you have a typical 15 set of interviews. Some people have much more. But there's videos related to this here, right here. Okay. All right. Other questions, thoughts? All right. So I think we will, let me see here, slideshow from the beginning. Didn't want to do that. So again, if you have additional questions or you think about questions after, feel free to reaching out. Feel free to reach out. I don't know what happened there from the current slide. If you have questions, feel free to reach out to Samantha, Ashley, or Melissa. Feel free to schedule with me. And I think that is, we have things about the qualitative. My computer's going on a blink here.
And we'll send you links to the recording. We'll also send you links to our other workshops. We have a qualitative workshop every second Thursday of the month. So we'll make sure you can join that too.
Terrific. Wish everyone a good rest of the week. Stay safe and healthy. And thanks for joining, and we'll see you next time. All right. Bye, all.